Hello everyone, and welcome to the Spark Streaming Example Code Along lecture. Because we will be using Spark Streaming and not the structured streaming that's still experimental in an alpha at Spark 2.1.1, what we need to do is use some older RDD syntax because we're going to be using a Spark context instead of a Spark session. So we're going to be building a very simple application that connects to a local stream of data, just our open terminal, through a socket connection. It will then count the words for each line that we type in into the terminal. Now the steps for creating the actual streaming connection is going to be the following. We'll first create a Spark context. It's very similar to the way we've been creating Spark sessions. Then, using that Spark context, we create a streaming context, and then using that streaming context, we create a socket text stream, essentially connecting via a socket our Jupyter Notebook or your .py file to the actual terminal. Then we're going to read in the lines as a dstream or a data stream. Then, once you actually have that data stream, the steps for working with the data are the following. First, we'll take in that input line. Remember, we're just reading this in batches, so we'll have these inputs of lines, which are essentially just a long string. And we want to split that into a list of words, just using a normal .split method. Then, we're going to map each of those words to a tuple that looks like this, a word comma 1. Where it's always going to be 1 as the second parameter in that tuple. Then we're going to group or reduce the tuples by the word, which is the key. And this is just a way of saying a reduce by key. Then we're going to sum up the second argument, which is always the number 1. And that allows us to essentially reduce all those tuples, which is going to be the words, comma 1, and actually get a word count. So you can imagine if I had typed in hello, hello, we would end up splitting hello, hello into a list of those two strings, hello, comma, hello. Then we would map each word to a tuple, hello, comma, 1 in one tuple, and then again, hello, comma, 1 in another tuple. And then we group or reduce the tuples by the word, which is the key. In this case, it's the hello. And we actually sum up the second argument, which is the number 1. So at the end, we would get something that looks like a tuple, except it would say hello, comma, 2. And that will then provide us with a word count in the form, like I just said, hello, comma 3 or comma 2, etc. for each line. Then, as a quick note, the RDD syntax relies heavily on lambda expressions, which are just quick anonymous functions, and luckily, the lambda expressions we use here are really quite simple and basic, so I don't think you'll have any problem understanding them. Okay, let's get started with this simple example. I'm going to open up my VirtualBox, and we'll open up 2 terminals and a Jupyter Notebook. Let's get started. Okay, here I am at my Ubuntu desktop inside my VirtualBox. I'm going to come over here and I will open a terminal, and then I'm actually going to open a terminal twice. So we'll have 2 terminals, and in the first terminal, that will be used for Jupyter Notebook, and the second terminal I will actually use for the streaming socket connection. So let's start a Jupyter Notebook, hit enter, and then eventually my Mozilla Firefox should, or Google Chrome, whatever you're using, should pop up, and we'll create a new notebook, and then I'm going to say view toggle header, view toggle toolbar, and since I'm running this on a VirtualBox, also what I'm going to do is say import find spark, and then the next step after import find spark is just find spark.init and then the file location for our spark. So I'm just going to copy and paste this. Essentially I just say find spark.init and then wherever spark happened to be installed on my VirtualBox machine. So then I'm going to run that, and now we should be ready to go. Okay, so the first thing you have to do is begin with the streaming. So we'll say from PySpark, import a Spark context. So we can run that, and then I will also say from PySpark.streaming, import a streaming context. And we can also use tab autocomplete that as well. Then we will say actually create these. So we'll say sc is equal to a Spark context. And we're going to be working with 2 working threads. So the actual syntax for that is local, and then square brackets, and then the number 2 for 2 local threads, and then whatever you want the application to be called. So we'll call this network word count. And you can actually check out all the details in these instructions, both in the notebook provided, but as well as the documentation. This is the example from the documentation. And then once we've created that Spark context, I'm going to say ssc for streaming context is equal to a streaming context, and then I'm going to pass in the Spark context and then 1. So the number 1 just means the interval is 1 second. So whatever type of streaming context I end up using, it's always going to be taking it in batches of 1 second at a time. So we can run that. And then I will say lines is equal to, off of this streaming context object, I will create a socket text stream. And this is going to create that D stream or data stream that will connect to a host name, and it's going to connect to a local port. So here I will say localhost and then pass in a port number that I'm pretty sure is not being used. So if you have a firewall, it may be blocked. It shouldn't really matter here because we're running on a VirtualBox. There's no default firewall like a Windows firewall here. We're just running Ubuntu. So we're going to say 9999 as our localhost port connection, and we can specify that when we actually go back to the terminal. So there's our lines. Remember, that's the actual string of data we're going to be typing in. And now I want to grab that string, that single line, and turn it into a list of words, which means I'm going to say words, I'm going to get that lines object, and then I'm going to say flat map, and this allows me to map something to those lines. And we're going to use a lambda expression where we take in each line and then we split that line based off white space. So just to make that clear, I'll actually specify that argument into .split. Okay, so now that we have that list of words, I want to create my pairs, which are those tuples I was talking about earlier, where I'm going to take my words and then I'm going to map each word to the tuple just consisting of the word, comma 1. Now that I have my pairs, I want to actually get my word counts. So we'll say word counts is equal to those pairs, and then I'm going to reduce by key. And you can essentially almost think of this as a group by mechanism, where reduce by key takes in a tuple and automatically reduces by the first argument in the tuple, and then you can do an operation with the rest of the second arguments. So we say pairs.reduce by key, lambda, and we're going to take in xy. So I'll actually type in word number, and then I'm going to say, actually this was probably not a good choice. We'll say num1, num2, and say num1 plus num2. Now this is just a little weird because it's not very intuitive what's going on here when you say reduce by key, and because of this kind of non-intuitiveness, it's actually why Spark Streaming is moving towards structure streaming and why Spark Context and RDD syntax is moving towards data frames in general, just because this sort of stuff is kind of a little weird to get your head wrapped around. But basically what's happening here is a lot of times when you're working with RDDs, you eventually get things and map stuff to be in tuple pairs, where you have a tuple and you have some sort of key as the first argument in the tuple or first item in the tuple, and then as a second item or element in the tuple, you have a number or a word, etc. And then once you have those tuple pairs, you say reduce by key, and what's interesting about this is using the RDD syntax, this reduce by key automatically knows that it's going to grab the first item in the tuples and use that as its key to reduce by or group by. And then the lambda expression or the function you pass in that takes in 2 arguments, it's not just going to apply that to just 2 tuples that happen to match the same word. It's going to keep reducing over and over until you just get one single instance of the word tuple itself on that key. So that's a little bit strange to wrap your head around the very first time you see it, but I think after we see some examples of the terminal, it'll make more sense. But keep in mind, this kind of weird, non-intuitive syntax is basically the whole reason people are starting to move towards data frames. Just going to take a little longer for Spark Streaming to get there, because streaming in itself is a little more complicated to convert. But hopefully by the time Spark 2.2 comes around, Spark Structure Streaming will be maybe out of alpha and into beta phase, and then by 2.3 it's a little more stable. Right now it's pretty experimental, and I really wouldn't suggest using it in a production environment. Okay, so we have our word counts. The very last thing I'm going to do is off this RDD, I'm going to say word counts, and then we can call ppprint, which is kind of like a pretty print. It's basically just printing everything with a nice format, these word counts themselves. Okay. So then what we're going to do is type in ssc.start, close parentheses, and I won't actually run this quite yet. So what we're going to do is come back to our terminal, and in the terminal I'm going to write nc space dash lk space, and then that port number, 9999. I'm going to hit enter, and then I'm going to start typing. But before I start typing, I'll come back to the Jupyter Notebook and actually start my streaming context. So let's run this. Okay, so my streaming context has started, and you can already see it's beginning to print every second. So let's start typing something. We'll say hello, hit enter, and then we'll say hello, hello, hello. And then we can write, this is a line with multiple words. Okay, so since I'm using the Jupyter Notebook, in order to kind of kill this, I either need to say ssc.await termination, which is going to wait for the computation to terminate. You can actually put limits on it, but since this is just running in one cell, it's kind of going to keep running for a really long time. So what I will do is say kernel up here, and then I'm going to just interrupt it to force it to stop. All right, so if I come all the way down here, I should stop seeing the print outputs. And if we come back up here, since it was taking it every second, we can see here that our word count was in fact actually working. This multiple line is a words with, etc. And then if we come back up here, we can see those counts, hello 3, and the very first one was hello 1, etc. And those are the very basics of working with Spark Streaming and also working with kind of the older Spark context RDD syntax. Now, if you want some more details on that, definitely check out the documentation page. This same example is on that documentation page, and they have a little more details on every step for you, as well as different links for more help. Okay, coming up next, we're going to set up everything we need for the actual Twitter example, and then in the lecture after that, we will go through it. Thanks everyone, and if you have any questions, feel free to post to the Q&A forums. I'll see you at the next lecture.